I would like to announce the first speaker and talk of this track. So meet Andrii Soldatenko. Andrii is a senior software engineer at Dynatrace, a frequent speaker at international conferences and Ukrainian meetups. He contributed in different Python and Go open source projects. Andrii will give a talk debugging Python applications inside k8s environment. So, Andrii, the stage is yours.
Hello, thanks for coming to my talk. My name is Andrii Soldatenko and I am software engineer originally from Ukraine, currently living in Vienna. I am working at Dynatrace and in my free time I am doing CrossFit and different gymnastics. Today we will talk how to debug Python programs inside Kubernetes environments. There are many different books and official docs, but there is no enough information on how to efficiently debug your programs, especially in cloud environments or inside Kubernetes. As a software engineer, never got any formal training in debugging, so I had to figure out this out of myself. I know I can't interactively ask you, but let's think together for a few minutes about different ways how to debug our Python programs. First, what I learned and might come to your mind as well, of course, is using prints. For instance, we can add in our source code, we can add as many prints as we want everywhere, and then we can see the output. Another idea can be logging. In general, logging or just tracking events happen when we run software, so we can track what's going on. And usually, like, developers add logging calls to their code to indicate that certain events have occurred. Next approach might be read eval print loop or just Python interpreter, so we can run interpreter and do some calculations or whatever. Or we can run a Python script with flag -e, and as you can see it will run your script and start interpreter session, so you can evaluate what's inside, so you can print or see variables or run some functions. A great technique to revisit observation and explain the problem to someone else. In this process, someone else is important, but even more important is that you are explaining the problem to yourself. This works because teaching someone else forces you to take different perspectives, and this helps you resolve inconsistency between what you assume and what actually observe. Since that someone else can be totally passive, you can even replace her with an object to talk to, like rubber debugging. And last but not least, of course, it's using debuggers. But first, let's discuss a little bit about, in general, how to add a debugger to a new language. Adding debugger for a new language or IDE or editor is not only a significant effort, but it's also frustrating that this effort cannot be easily amortized over multiple development tools, such as different APIs or different features. That's where the idea comes with this debug adapter protocol, is to abstract the way how the debugging support of development tools communicates with debuggers or runtimes into a protocol. Since it's unrealistic to assume that existing debuggers or runtime adopt their protocol anytime soon, we rather assume that an intermediate component like the debug adapter adapts an existing debugger or runtime to debug adapter protocol. This protocol makes it possible to implement a generic debugger for a development tool that can communicate between different debuggers and debug adapters. In Python, none of them well-known debuggers support DAB protocol, unfortunately. This is from official documentation, and we will discuss later which one does and why I'm showing you all this big list. But first, let's for a second return to general approach, how to debug a program locally on your environment or like on your local dev machine. And in general, it's very simple. We have a main program. In my example, it's just basic fast API application. And the best approach, or the simplest approach, is to just use standard Python debugger or library, which calls PDB. You can just import it and set trace, and we are good. Also, we can use PyCharm or VS Code and delegate all these steps to IDE. But nevertheless, we add this line, and then when we run this application and we reach this path of the code, the interactive REPL session will be shown, and we can sniff and jump through the code, print values of variables, set new breakpoints. In my case, I run L, which just lists the current program and line where I set a breakpoint. So you can do it via terminal, as I prefer, or you can use PyCharm or VS Code and using all visual breakpoints and buttons. But usually on production usually we call it you build it, you own it, which means just development cloud native application for Python is not so simple. It's hard because of different factors. Traditionally, running cloud apps means building image, push image to the registry, and then deploy it to Kubernetes or any other orchestration tool. Of course, create pods, deployments, and many replicas for a given app. So, which means we have a sample Docker file, usually multi-stage, and we build and deploy to some platform which can manage containerized workload and services. So let's define a problem which we're trying to solve. We have a Kubernetes which run a pod, and under the hood it runs a Python app. So we can easily run debugger locally and debug it. And let's focus on pod because this is the most minor deployable units of computing that can create and manage, for example, in Kubernetes. So now we are moving to our main problem we should solve today is how to debug containerized Python applications. So let's focus on it, and in particular how to run remote debugging, because usually this container running somewhere we can't control. So let's think a little bit. Previously we ran app and debugger in the same host, and it's not usually the case. Remote debugging is useful when the process is not associated with a controlling terminal, or when, for example, PDB or debugger cannot use a controlling terminal, or when we, for example, running it somewhere like in Kubernetes. So to use remote debugging, we should utilize remote debugging features. So first example or first approach how to do it is VS Code. So since we don't want to debug Python program on the same dev machine, we need to tweak, for example, our VS Code to do it. How to do it? So first step is simple. We create a line JSON which split like running debugger and attaching, or like connecting debugger. And here we say like we want to attach to debugging web server and using our VS Code client, so we can interactively debug it. And a few slides before we discussed this deb protocol, so which gives us opportunity to do it. And how? It's a reasonable question. We are installing Python package debug.py, which written by and hosted in Microsoft repo. And this package allows us, and this package implements this debugging adapter protocol, which gives us opportunity to run debugging server together with our application, and then waiting for clients, so debugging clients. And so we will adjust our Docker file, and we can, next steps are very simple. We will try to build this Docker image, and of course we can run it. And as you can see, I run it, and I forward few extra ports. So one is for application and another one for debugger. And next step is as well as simple as previous two. We can open our application in VS Code, and we can click run and debug. It will ask us where to connect, and we will connect to our running Docker container locally, and we can start this debugging session using VS Code. If you're not using VS Code like me, for example, or you prefer more terminal-based debugging, there are a few other approaches how we can achieve same task. One of it is using standard PDB, but slightly patched version, which names PDB clone. It's like original PDB with few modifications, and one of the modifications is allow you to set trace remote with host and port, and put your like debugging line to your source code and run it. And after, you can simply telnet to this port and like host, and it will start debugging session like normal PDB debugging session. And you can again sniff to the code, you can jump, you can click next as a shortcut as N, you can print some variable names, and you can repeat. So unfortunately, it does not work with Python 3.12, but it works well with 3.11.9. Another debugger which also has ability to run like the remote debugging session is PUDB. It's slightly different debugger. It has more features than this patched PDB version, and it has kind of UI. So if we tweak our Docker file and install this PUDB, for example, separately, and also we have to expose a port for this debugging, and so we can connect to it and we run it. And of course, in our source code, we can use the same idea. We set trace, and this is our breakpoint for someone who is not familiar, but it's just like put a breakpoint, but in written form. There is a shortcut in new versions of Python like breakpoint, but since we are not using standard, we have to write it down. One can ask why we set term size and host. So to connect outside of the Docker, and because PUDB has UI, terminal-based UI, it requires some basic configurations. And again, we build container and we run it in one terminal. We just run it, and as you can see, it's even suggesting you that you can telnet to the host and port and waiting for clients. And if you run separate terminal and connect it to it via telnet, you will see this very old school screen. Reminds me times when we did some C++ and Pascal at university. So it just a hello message. Of course you can disable it, and it's same. It shows you source code. You can jump through code. You can debug it as usually interactive debugging using next, continue, set some breakpoints. You have a REPL in the bottom of the slide where you can print variable names and change something, etc., etc. So which gives you more visual debugging, not like VS Code, but more in terminal, but not like PDB, but with more or less fancy UI than just like one line of the code. Of course, it depends on your taste, but it's how you can achieve it. But now, so since we did all the groundwork required before we start debugging inside Kubernetes, now let's focus how to debug Python app inside Kubernetes. I assume all of you know how to debug pods, check the state, etc., read logs. So I will focus only on debugging running pods. So if pod is not running, or you don't have permissions, or network is not working, you can separately troubleshoot it. I am more about logical problems. So when your app is running, but there's like business mistake or something else. So first tip or trick which we will focus is let's tweak a little bit our Docker file and Docker entry point. Why? Because it will help us to easily manipulate with environment variable and disable this like remote debug port using debug py, for example, for VS Code. It doesn't matter which approach you select, same ideas, just different tools. Again, depend on your taste. And like instead of each time tweaking your Docker file, we can just create this entry point and you can run your app, and then you can easily switch and restart your pod inside Kubernetes with this new environment variable. So it's a very basic logic to override how to run app with or without debugger. Yeah, so you can focus that the only important is checking if this environment variable is set. Then we run with wait for client, and final Docker file will look like, instead of using CMD and like running Python directly, we just run entry point, and of course we have to copy entry point and make sure that there's correct permissions. So next step is to create Kubernetes pod manifest, which on my slide, which just assuming we build an image and we push it to the registry. I did it beforehand, and yeah. And as you can see, I provide this debug port in my sample file. So it's time for a little bit demo. So to demonstrate how it works, beforehand, what I did, I deployed app which from my site, from the sample. It's my image, which has only environment variable with this remote debug port, and if you run logs, you can see it's running app. So it's running app from the beginning, and yeah, and that's it. And now I will use VS Code to demonstrate, just because it's easier and I don't need to tweak any code. As I already told you, assuming you have changed this launch file, so you will connect to localhost and port, and but someone can figure out that we don't run the pod locally, it's running in my cluster and I can't connect to it, and you're right. So first we need to, for example, port forward from your cluster to your local machine, your app and debugging port. It's one example how you can achieve it, assuming you have access to this cluster. And when you port forward, then you can just go to your application and run debug. It will connect to your application. Let's see if it's connected. Yeah, it's connected. And yeah, and now I will just refresh the page of my app, and because I have a breakpoint to the root, you can see the debugging session has been started. I can do something. I can see the state of my app. I can go to another handler, and I can go next step. And yeah, you can see here that debugging session is started, and I navigated to the main page. I can release it, and yeah, and it works. So I can repeat it as many times as I need, reconnect, run debug, refresh page, and yeah, and start debugging. So, which is very easy. Yeah, let's return to our slides very quickly. Okay, so live demo is over, and we are going to next step. So it was just one way how you can do it. So you have access to Kubernetes, and you port forward to localhost, and then you run your debugger locally, and you connect to the cluster with remote access. Sometimes I wrote this diagram to explain why we need other ways to debug. For example, if your container image includes debugger client, if yes, you can just connect through, for example, through pod to this container and connect, because you have network access. If no, by different reasons, you probably can run another container or another pod, which usually in Kubernetes world calls like ephemeral container, and yeah, it will help us to, for example, yeah. So I will show you some more examples. So what it does, it's this ephemeral container are useful for interactive troubleshooting when we can't exec to pod because of different reasons. Container is crashing, or image does not include some utilities we need, or in a worst case it's distroless image. So what we can do, we can run this kubectl debug command, and we can specify the target. And interesting, we can share processes between your running application and the application in another container. And as you can see on my screen, I run a top, for example. So I see from another container, I see my main container, and I see that, okay, here's a running debugger, and I can connect from one container to another container. Yeah, the only important note that the target parameter must be supported by the container runtime. So it's not for every container runtime, but it's outside of the scope of this presentation. But anyway, so as I already told, you can do it with sharing, or you can copy, for example, existing container, and also again share the processes, and or for example, you can you can run debug container, and from the debug container you can telnet to app. So in this case you don't need to port forward or anything, so you can run debugger directly, and you can debug if you need only directly from Kubernetes. And like last but not least important nuance is when we build an image, we have to add this SHA commit of the Docker of your source code, because sometimes when we debug locally or from container, we need to share proper code version, and not like mistake and run one version against another. There will be a conflict between client and server during debugging session. So if you burn git commit into Docker image, and by just very stupid environment variable, and during building process you can get current hash, assuming you like using something like git ref parse head as your git hash environment variable or a parameter, and then you run this container, you see that environment variable is set it properly, or you can write it to the file if you have inside container. Then you can connect and see which exactly version of source code makes sense, and then locally you can check out to this version, so you can debug exactly version you're running on this specific environment. Sometimes it's very important. Yeah, many people don't know this tool. Someone is using it, and I found it's very useful as well, because if you do many stuff and debugging different clusters, and I demonstrate it in my live demo, I use this tool. It's k8s. If you never try it, highly recommend. It's just terminal based like UI to interact with your Kubernetes clusters, and you can easily jump between pods and any other resources, and you can watch on logs, on changes, you can interact with resources, so a bunch of stuff. My favorite feature is using plugins, because if you more frequently debug different containers, you can for example create a plugin which on the hotkey will run debug container, and as you can see, you can pass some different names and no need to manually type it, and it will troubleshoot and debug your containers. And also you can build your own image with tools. Like on the slide you see the tool with well known in Kubernetes world, which has some networking. You can also build something you need, like I show you, you can just connect using telnet, which is very minimum, but this image has telnet. If you, I don't know, if you need very specific requirements, you can add more. I have my own image, which has some specific tooling I need, and I usually using it when I need it. I try to make it very small, so yeah, I will link it in the end. Yeah, so to not overload you, let's just summarize what we discuss. First, the debugger does not fix your bugs, it just runs them in slow motion. Don't forget to add some details to your Python apps inside images, otherwise you will lose the version control tracking, because usually we deploy image with source code and there is no enough information, and we not include Git directory inside our images to reduce the size. Of course, you have to scale down your traffic on your Kubernetes application instance to avoid misses of requests to your pod, because I show you only simple pod with one instance, but usually in production you have deployment which has like 5 or 20 instances of app, and if you try to debug it and you deploy it with tricks I show you, and you try to navigate to specific URL of your app, it will, so Kubernetes will route your request to specific pod, and but you connect it to different ones, so you will miss the request. So for debugging needs, scale down it as much as you can. Yeah, use debuggers as much as possible. From my personal practice, I see people still using prints and people spending hours just trying to guess how it works instead of just go and debug it and find the problem in minutes. Of course, automate your routine. Even debugging is slow and we do it half of the day, so if you have proper hotkeys, plugins, it will help you to speed up your development journey. So future reading, yeah, I added a couple links mostly for my personal repos. One is my image debugging, so image Docker image, which you can use for debugging purposes. It's just inspiration from others. It's not like you must use it. It's just you can go and check how I did it, and you can build your own debug image for your needs with your tools, and make sure it's small so you can easily like reuse it somewhere. I have similar project with how you can do it for Golang apps, so you can revisit it. And the last link is all codes and snippets and examples and Docker files I show in this presentation, so you can go check out it and try it out.